In this video, we'll be looking at how to simplify radicals that don't just involve a number, but involves a number, it involves variables, so it's a little bit tougher than what you've probably seen before. So you may, if you're watching this video, you may already know how to simplify something like radical 50, but seeing the x, the y, the z is what you find challenging. All right, so in this case, or invisible radical, the invisible index, the index that we can't see is 2. So this video is all about square root. All right, but I'll try to make it general so you can apply this to other radicals as well, cube root, fourth root, so on and so forth. Okay, so you want to ask yourself, what is the largest factor? So we're going to start off with a number. The largest factor of 50 with a perfect, in this case, square root. And that's 25. 25 has a perfect square root. But we can't just write 25 and leave it alone. We have to pair it up with what will give you 50. So 25 times 2 gives you 50. All right, so I'm just rewriting right now. I'm taking out those factors with those perfect square roots. All right, so side note, how do you know whether or not a variable has a perfect root? Now, it looks hard at first, but once you know, then you really know. It's actually much easier than dealing with the numbers. So we know a variable, I'll say it first and then I'll write it down. We know a variable has a perfect root if its exponent is a multiple of the index. And that's a big test of vocabulary here. So I'll point out everything that I just said. First, let me write it down. So we know a variable has a perfect root. Side note. A perfect root if the exponent, I'll shortcut here, is a multiple. Oh boy. I don't know if I can fit this, but it's all very important. So I'm going to say is a for multiple of the index. I fit it, kind of. Okay, what do I mean by that? So in this case, our index is 2. And in this case, our exponent is 2. So here for our x's, our exponent is a multiple of the index, so this is a perfect square. I will repeat. Index is 2, exponent is 2, which means that in this case, our exponent is a multiple of the index, so that's a perfect square. So all I'm writing in here, I'm factoring out my perfect square, so x squared is already a perfect square, so I'm going to write that down because it's my largest perfect square. That's a factor of x squared. It is itself. All right, that was a little weird. It will get a little bit less weird here. So is 5 a multiple of 2? It's not. But what's the biggest number that could be here that is a multiple of 2? Right, the number that comes right below 5, which is 4. So the factor that I'm taking out here is going to be y to the 4th. Now that is a perfect square because that 4 is a multiple of 2. But I can't just write down y to the 4th because I can't change the value here. So I have to write another y. So now that this together is y to the 5th. I'm not changing any values. I'm just taking out the largest number or the largest factor with a perfect square. All right. Looking at z, what is the largest factor of z to the 7th with a perfect square root? With a perfect square root. Well, if you said that the largest factor of z to the 7th with a perfect square root is z to the 6th, you are correct. But again, we can't just write z to the 6th and keep it moving. We have to have that z attached on to the end here. So now together, this is z to the 7th. All right, so I'm going to rearrange this. I'm going to put everything with a perfect square root, a perfect root, on one side and everything else on the other side. So this is my commutative property here, totally allowed to rearrange it. So 25 has a perfect root, so does x squared, so does y to the 4th, and so does z to the 6th. And everything else is, we have a 2, we have a y, and we have a z. Okay, so now we can square root everything over on this side. The square root of 25 is 5. The square root of x squared, so the square root of x squared is x. We're just halving, because that index is 2. In order to figure out the square root, we're going to have to divide by that index. So the square root of x squared is x, and that makes sense, right? Because x times x is x squared. The square root of y to the 4th, we're halving that exponent here. Sorry, I said index earlier, I meant exponent. Halving that exponent. The square root of that is y squared, which makes sense because y squared times y squared, adding the exponents, you get y to the 4th. And we're going to square root the z to the 6th, and again we're halving that exponent, and so we get z to the 3rd, which makes sense, again, because z to the 3rd times z to the 3rd is z to the 6th. We're adding those exponents. All right, but unfortunately, or not that unfortunately really, we are not able to square root any of these, so we have to keep them under the radical sign. So we have here radical 2yz. And now, since none of those under the radical sign have a factor that has a perfect root, that is the most simple answer that we can get here, and we have simplified our wonderful expression.